Good morning, all of you. My name is HARIBABU. I am a chemistry lecturer. I have 15 years experience in JEE, mains and advanced. Today I am going to discuss chemistry memory based questions phase 2. This exam was conducted on 24th Jan 2025. First question in this section is, arrange the following in ascending order of wavelength. He given different types of electromagnetic radiations like this. First one is lambda 1 infrared. Second one is lambda 2 micro. Third one is X-ray lambda 3. X-ray. Fourth one is lambda 4 UV region. UV visible. UV. So what is the order of wavelength of these different types of electromagnetic radiation? He given first question like this. So already you know about electromagnetic spectrum. An arrangement of different types of electromagnetic radiations in increasing order of their wavelength or decreasing order of frequencies is called electromagnetic spectrum. There are different types of electromagnetic radiations: X-rays, gamma rays, UV rays, visible rays, IR rays, like that. So what is the order of different types? What is the order of wavelength of different types of electromagnetic radiations? First one is, already you know about this. So first one is the cosmic rays. Cosmic rays is less than wavelength of different types of electromagnetic radiations are like this. That is a fixed. So cosmic rays. Next one is the gamma rays. Next one is X-rays. Next one is UV rays. Next one is visible rays. Next one is IR rays. Next one is microwaves. Next one is the radio waves. Actually, this is the order of wavelength of different types of electromagnetic radiations in electromagnetic spectrum. So in this case, we given 4 different electromagnetic radiations. First one is IR, micro, X-ray, UV. So what is the correct order in this case? If you know this point, order of wavelength of different types of electromagnetic radiations, then you can write correct answer for this. So what is the correct order in this case? First one is X-rays. Order of wavelength of these 4 electromagnetic radiations are like this. First one is X-rays, less than. Second one is UV rays. UV rays. Next one, IR rays. Next one, microwaves. So that is the order of wavelength of these 4 different types of electromagnetic radiations. He given 4 different options in this case. First option is lambda 3 is less than, lambda 4 is less than, lambda 1 is less than, lambda 2. Second option is lambda 3 is less than, lambda 1 is less than, lambda 4 is less than, lambda 2. Third option is lambda 2 is less than, lambda 1 is less than, lambda 4 is less than, lambda 3. Fourth option is lambda 1 is less than, lambda 4 is less than, lambda 2 is less than, lambda 3. So which one is correct option in this case? Lambda 3 belongs to X-rays. Next lambda 1 belongs to IR. Next it is micro. Lambda 4 means UV. So what is the correct order in this case? First one is X-ray, means lambda 3. Next UV, lambda 4. Next IR, lambda 1. So it is the correct option in this case. Like this you can understand order of wavelength of different types of electromagnetic radiations. That is from electromagnetic spectrum. That's the first question in this case. Second one, next question. He given second question like this. He given electronic configuration of complex compounds. T2G3 and EZ1. Electronic configuration is possible in configuration is possible in. He given four different options like this. First option is weak field ligand with a high spin. Second option is weak field ligand with a low spin. Third option is strong field ligand with a high spin. Fourth option is strong field ligand with a low spin. Already we know about the complex compounds. So in this case, he given T2G3 EZ1. If it is a complex compound, any complex compound or electronic configuration of the central metal atom, generally degenerated d orbitals splits into two types of sets. One is the T2G set and another is EZ set. There are 5 types of d orbitals. These are 5 d orbitals are classified into two sets. One is a T2G set, another is EZ set. So whenever central metal ion is bonded with a strong field ligand, then electron pairing takes place against Hund's rule. Then it becomes a low spin complex. Whenever central metal ion is bonded with a low weak field ligands, whenever central metal ion is bonded with a weak field ligand, then there was no change in electronic configuration of central metal ion. In this case, then it represents a high spin complex. So in this case, the T2G3 EZ1. Whenever central metal atom having this type of electronic configuration, then that is bonded with a weak field ligands. Weak field ligand. So weak field ligand with a high spin is correct answer in this case. Weak field ligand with a high spin, because number of unpaired electrons in this case 4. Whenever number of unpaired electrons increases, spin of the complex also increases. So first one is correct option. No chance to strong field ligand, because whenever central metal atom is bonded with a strong field ligand, then electron pairing takes place. That is against Hund's rule. So first option is correct. Next question in this case, third question. Question number 3. In this case, he given percentage of carbon, oxygen in an organic compound. So percentage of these elements are like this. Percentage of carbon in given compound is 52.2%. Next, percentage of hydrogen in given compound is 9.2%. Next, percentage of oxygen in given compound is 36.6%. He given percentage of 3 elements in a given compound. Okay, its molecular mass is 132 grams. Molecular weight of given compound is 132 grams. So its molecular formula is, what is the molecular formula of the given compound? The given percentage of 3 elements which are present in given compound. Like this, and molecular weight 132, we have to find molecular formula of the compound. So how do you find molecular formula of the compound? Already you know how to determine, how to find empirical formulas and molecular formulas if percentage of elements are given. So in this case, percentage of carbon is equal to 52.2 percentage. Percentage of hydrogen is equal to 9.2 percentage. Percentage of oxygen is equal to 36.6 percentage. So what is the atomic weight of carbon? Atomic weight of carbon is equal to 12. Atomic weight of hydrogen is equal to 1. Atomic weight of oxygen is equal to 16. Find number of atoms in this case. Number of atoms is equal to number of atoms. Take the ratio between these two. So number of carbon atoms in given compound is equal to 52 by 12. Number of hydrogen atoms is equal to 9.2 by 1. Number of oxygen atoms is equal to 36.6 by 16. That is equal to 52 by 2 is equal to 4.6 nearly. Next 9.2. 36.6 by 16 is equal to 2.3. So which one is least value in this case? 2.3. So again these are divided with the 2.3. So 4.6 by 2.3, 9.2 by 2.3, next 2.3 by 2.3. In this case 4.6 by 2.3 means 2. In this case 4. In this case 1. So therefore number of carbon atoms is equal to, therefore number of carbon atoms is equal to 2. Number of hydrogen atoms is equal to 4. Number of oxygen atoms is equal to 1. So therefore empirical formula of the compound is equal to C2H4O. Molecular weight of empirical formula is 44. But given total molecular weight of the compound is equal to 132. So therefore, already know one relation, that is the molecular formula is equal to N into empirical formula. Find N value. N is equal to molecular formula. How much molecular formula weight? 132 by 44. Empirical formula weight. That is equal to 3. So therefore, molecular formula is equal to N into empirical formula. So that is equal to N value 3. Empirical formula is nothing but C2H4O. C2H4O, then it becomes C6, 3 into 4, H12, number of oxygen atoms 3. So this is the molecular formula of the compound. C6H12O3. In this case, see given 4 options like this. First option is C6H12O3. Second option is C4H8O2. Third option is C6H12O2. Fourth option is C6H12O6. So correct option is 1. C6H12O3 is the correct answer. Next question number 4. Find the total number of sp, sp2 hybridized carbon atoms in given compound. Given one compound like this. Given one compound like this. So find total number of sp and sp2 hybridized carbon atoms in this. Already you know, whenever carbon atom is bonded with a 3 sigma, sp2, whenever carbon is bonded with a 2 sigma, sp, whenever carbon is bonded with a 4 sigma bonds, sp3. So in this case, this carbon is bonded with how many sigma bonds? Double bond means 1 sigma, 1 pi. So it is sigma, it is 1 sigma, it is another sigma. So this carbon is bonded with a 3 sigma bonds, so this is sp2. It is also sp2. It is also sp2. This is also sp2. It is also sp2. but it is bonded with the triple 2 sigma, triple bonded carbon. So it is sp. It is also sp. This is also sp. It is also sp carbon. So number of sp carbons in this case. Number of sp carbons in this case 3. Number of sp2 carbons 1, 2, 3, 4, 5. So total number of sp and sp2 hydrogen carbon atoms is equal to 8. So it is the correct answer in this case. Next question. Question number 5. Question number 5. In this case, given percentage of carbon in a hydrocarbon. A hydrocarbon X that has molecular mass 80 grams contains 90% of carbon. Find the degree of unsaturation in X. Degree of unsaturation means number of double bonds, rings, triple bonds like that. A hydrocarbon X that has molecular weight 80 grams, that has molecular weight 80 grams, contains 90% of carbon. Find degree of unsaturation in X. Find degree of unsaturation in X. Find degree of unsaturation in X. So first of all, you have to write the given data. So in this case, the given molecular weight of compound is equal to 80 grams. Molecular weight of given compound is equal to, that is nothing but hydrocarbon is equal to 80 grams. Percentage of carbon is equal to 90%. Just assume total percentage is equal to 100. Out of 100, 90% is carbon, remaining percentage is hydrogen. So 100 minus 90, 10. So percentage of hydrogen indirectly in this case is 10%. If percentage of elements are given, then you can find number of atoms in that. So therefore, atomic weight of carbon is equal to, already know, atomic weight of carbon 12, atomic weight of hydrogen 1. Then how do you find number of atoms in this? Number of atoms is equal to given percentage by atomic weights. So 90 by 12 in this case, 10 by 1 in this case. 10 by 1 means 10 and 90 by 12 is equal to how much in this case? That is approximately its value 7.5. 7.5. So which one is least value in this case? 7.5. So again you have to divide these values with the smallest value 7.5. 7.5 by 7.5, that is equal to 10 by 7.5. So here 1. So its ratio approximately 3:4, 1.33. So convert that fraction values into simple integers. So that is equal to 3, that is equal to 4. So the ratio between carbon and hydrogen is equal to 3:4. That means indirectly number of carbon atoms is equal to 3. Number of hydrogen atoms is equal to 4. So therefore empirical formula is equal to C3H4. Empirical formula is equal to C3H4. Molecular weight of this is 40. But given, empirical formula weight is 40. But given molecular weight 80. So therefore molecular formula is equal to N into empirical formula. Empirical formula weight 40. So molecular weight formula 80. So 80 is equal to N into 40. Therefore N is equal to 2. So simply you can write molecular formula like this. Molecular formula is equal to 2 into C3H4. So then it becomes C6H8. C6H8. Degree of unsaturation in this case is equal to 3. C6H8. Already know degree of unsaturation formula X plus 1 minus Y by 2. X is the number of carbon atoms, Y is the hydrogen atoms. So X value 6 plus 1 minus Y value 8 by 2. So that is equal to 6 plus 1, 7 minus 4. 7 minus 4 is equal to 3. So therefore degree of unsaturation is equal to 3. Degree of unsaturation is equal to 3. So 3 is the correct answer in this case. Next, question number 6. In this case, given in the carriers method, 0.25 grams of organic compound is heated with fuming HNO3, then AgNO3 is added to it. It gives 0.15 grams of AgBr. If molecular mass of AgBr is 188 grams, then find mass percentage of bromine in that given organic compound. So first of all, you have to write given data. So in this case, weight of organic compound is given weight of organic compound is 0.25 grams. 0.25 grams. Weight of AgBr formed is 0.15 grams. 0.15 grams. Molecular weight of organic compound is 188. Molecular weight of AgBr. Molecular weight of AgBr is 188 grams. Molecular weight of AgBr is 188 grams. Find the percentage of bromine according to Carrier's method. So according to Carrier's method, percentage of bromine is equal to formula atomic weight of bromine by molecular weight of AgBr into weight of AgBr formed by weight of organic compound into 100. So with the help of this formula, we can find percentage of bromine according to Carrier's method. So therefore, percentage of bromine is equal to, so weight of AgBr, atomic weight of Br is equal to 80 grams. Atomic weight of Br is 80 grams. Molecular weight of AgBr given 188. Already know, you can calculate. Into weight of AgBr formed in this case 0.15. 0.15 grams by weight of organic compound given in this case 0.25 into 100. So that is equal to if you calculate this 0.15 into 100, so 80 into 15 by 188 into 0.25, that is approximately 25.53. 25.53%. This is the percentage of bromine in given compound. We can calculate this percentage of bromine according to Carrier's method like this. Next question. Next question number 7. Question number 7. In this case, given 5 ionization energies of an element X. Those IE values are like this. I1 of the element is In this case, given I1 of the next element is 500 kilojoule per mole. Kilojoule per mole. I2 of that element is 600 kilojoule per mole. I3 of that element is 2000 kilojoule per mole. IE4 of that element is 2200 kilojoule per mole. IE5 of that element is 2600 kilojoule per mole. He given 5 ionization energies of X element like this. It is IE1, it is IE2, IE3, IE4 and IE5. Okay. Then we given data. Find out the group number of that element. Based on these 5 ionization energy values, we have to find group number of that element. So with the help of these 5 IE values, you can find group number, because if you observe these 5 values, IE1 value is 500, IE2 is 600, IE3 is 2000. There was a big change in IE2 and IE3. This is called a jump in ionization energy. Jump in ionization energy was observed in between IE2 and IE3. Jump in IE values that was observed in between IE2 and IE3. Whenever jump in ionization energies was observed in between second and third, then the element belongs to second group. Second A group element. Then that element belongs to second A group. For example, we have taken magnesium. One second A group element, magnesium. Magnesium electronic configuration 1s2. Next 2s2, 2p6. Next 3s2. 3s contains 2 electrons like this. So in this case, if we remove first electron, then that is called IE1. The amount of energy required to remove first electron from magnesium is IE1 of magnesium. We can remove first electron and second electrons easily, but we can't remove third electron because the third electron was in stable electronic configuration, noble gas electronic configuration. That's why there was a big jump. There was a large difference in IE values of second and third. So that element belongs to second A group, no doubt, because jump in ionization energy was observed in between second and third. Whenever jump was observed in between second and third, then that element belongs to second. Next question. In this case, is given like this. Next question number 12. Question number 12. Oh. Next question. Next question number 8. Question number 8. In this case, he given molar mass and observed molar mass and a normal molar mass. He given observed molecular mass and a normal molecular mass of MX2 molecule. MX2 molecule. Observed molecular mass is observed molecular mass or weight is 65.6 grams. Normal molecular weight is 164 grams. Find the percentage dissociation. Find the percentage dissociation. Percentage dissociation. Alpha. Percentage of alpha. How do you find percentage of dissociation in this case? In this case, you given observed molecular weight of MX2 65.6 grams. Normal molecular weight of MX2 164 grams. We have to find percentage of alpha or dissociation. So here we know one important term in solutions, that is the Van der Waals factor I. Van der Waals factor I is equal to formula is there, that is normal molecular weight by observed molecular weight. There is a formula to find Van't factor I for given compound. Already you know given compound, that is mx2. mx2, whenever it is whenever this compound undergoes dissociation, then it gives m plus 2 plus 2x minus. So number of ions in this case, it is 1 cation and 2 anions. So 1 plus 2 is equal to 3. So it contains a 3 ion. Whenever mx2 compound undergoes dissociation, then it gives 3 ions like this. Out of 3, 1 is cation, remaining 2 are anions. So here Van't factor I is equal to normal molecular weight by observed molecular weight. Find this value in this case. Normal molecular weight is 164 grams. Observed molecular weight is 65.6 grams. Find this value. So 164 by 65.6 is equal to 2.5. We know the relationship between degree of dissociation alpha and the Van't factor I. Alpha is equal to, we know that alpha is equal to I minus 1 by n minus 1. Alpha is equal to I minus 1 by n minus 1, where n is 3. So that implies alpha is equal to I value in this case 2.5. 2.5 minus 1 by n value 3 minus 1. So that is equal to 1.5 by 2. 1.5 by 2 means 0.5. It is alpha value, but we have to find percentage of alpha. Percentage of alpha is equal to 0.75 into 100, that is equal to 75%. So degree of dissociation percentage is 75%. Question number 9. In this case, we given one organic chemical reaction like this. That reaction is like this. He given one product, one reactant like this. IBrCl. This compound reacts with silver cyanide AgCN. Whenever this compound reacts with AgCN gives P. It is a major product in this case. What is P? We given 4 different options like this. First option is IBrCN. Second option is IBrNC. Third option is NC Cl Br. Fourth option is Br Cn Cl. So what will happen whenever given compound reacts with AgCl? AgCN. What is the nature of bond between Ag and carbon in this case? Already you know. It is an example for SN2, substitution reaction. Substitution reaction. Substitution reaction. So in this case, AgCN, it acts as a nucleophile in this case. So nature of bond between silver and carbon is a covalent bond in this case. It is covalent bond. So here, lone pair of nitrogen involved in substitution reaction. Whenever given compound reacts with the AgCN, then in this case, this chlorine atom is replaced by nitrogen. Substitution takes place at a benzylic carbon. So that gives Second option, like second option. In this case, nitrogen, lone pair of nitrogen involved in substitution reactions. There was no involvement of carbon. We can't break ADCN bond in this case. So because bond between these two is covalent, that's why lone pair of nitrogen involved in substitution. So finally it becomes isocyanate like. So second option is correct answer. Suppose in case of ADCN, if it is KCN, then that gives first option. So this chlorine is replaced by cyanide. So in this case we can't replace iodine and bromine because both are bonded with the aromatic ring. In this case, if you remove bromine, then it becomes beryllium cation. If you remove this, then it becomes aryl cation. If you remove this Cl, then this carbon becomes benzyl. So benzyl carbon is more stable. That's why substitution takes place at the benzylic carbon. So it gives second option. Second option is correct. We can't replace iodine and bromine because both are bonded with the ring. But in this case, chlorine is bonded with the benzyl carbon. Benzyl carbon is more stable than aryl carbons. Aryl carbocations. Next question. In this case, he given one matrix matching. He given column 1 and column 2. Question number 10. Column 1 and column 2. Column 1 contains 4 options. First option is Itard reaction. Second one is Gattermann reaction. Third one is Gattermann-Cope reaction. Fourth one is the Stephen reaction. Next, column 2, he given reagents. First one is SnCl2 in the presence of HCl. Q is chromyl chloride, CrO2Cl2. Next one is Cu plus HCl. Next one is Cu plus HCl in the presence of anhydrous AlCl3. Anhydrous AlCl3. He given 4 named reactions and 4 different reagents like this. Suppose if you take first option, Itard reaction. What is Itard reaction? In Itard reaction, aromatic hydrocarbons are converted into benzaldehyde. So which one is reagent in a Itard reaction? Chromyl chloride. Chromyl chloride acts as a reagent in a Itard reaction. Chromyl chloride acts as a reagent in Itard reaction. So in this case, he given 2 different columns like this. First one contains 4 named reactions. Second column contains 4 different reagents like this. If you take first one, Itard reaction. Itard reaction means, in this case, methyl benzene is converted into benzaldehyde in the presence of chromyl chloride. Next, if you take a Stephen reaction, what is the importance of Stephen reaction? In Stephen reactions, cyanides are converted into aldehydes. So which one is a reagent in this case? SnCl2. SnCl2 in the presence of HCl. It acts as reagent in Stephen reaction. In Stephen reaction, cyanides are converted into aldehydes. That is the use and importance of Stephen reaction. Next, Gattermann reaction. What is the use and importance of Gattermann reaction? In Gattermann reaction, benzene diazonium chloride PHN2 plus Cl minus is converted into chlorobenzene. This is a Gattermann reaction. In this case, reagent is Cu and hydrochloric acid. Last one in this case, Gattermann-Cope reaction. In this case, benzene is converted into benzaldehyde. So in this case, reagent is carbon monoxide in the presence of HCl. It is a reagent. This process takes place in the presence of anhydrous AlCl3. That is about matrix matching. Next question. Question number 11. Question number 11. In this case, given like this. Calculate the overall activation energy. Calculate the overall activation energy. Calculate the overall activation energy. Given overall rate constant K is equal to under root K1 into K3 by K2, and again he given EA1 value, EA2 value, EA3 value. EA1 value is 60 kilojoule per mole, 60 kilojoules. EA2 is 40 kilojoules. EA3 is 20 kilojoules. 20 kilojoules. Calculate overall activation energy. Already you know about, this is from chemical kinetics. Already you know about Arrhenius equation. That is K is equal to A into e power minus EA by RT. This is called Arrhenius equation. So he given overall rate constant K is equal to under root K1 into K3 by K2. So here in this case we can write K means A into e power minus EA by RT. That is equal to under root. In place of K1 we can write e power minus EA1 by RT into e power minus EA3 by RT by e power minus EA2 by RT. So here it is a constant. You can neglect this. So e power minus EA by RT is equal to under root e power minus EA1 by RT into e power minus EA by RT by e power minus EA2 by RT. Means indirectly in place of K1 we have taken e power minus EA by RT. In place of K3 e power minus EA3 by RT. In place of K2 we have to take e power minus EA2 by RT. So therefore we can write like this. Minus EA1 is equal to, or minus EA is equal to EA2 minus EA1 minus EA3 into 1 by 2. From this you can derive like this. EA is equal to EA2 minus EA1 minus EA3 into 1 by 2. Find EA value. Therefore, EA is equal to, he given EA1, EA2, EA3 values like this. EA1 is 60, EA2 is 40, EA3 is 20. Therefore, overall activation energy EA is equal to 1 by 2 into 60 plus 20 minus 40. That is equal to 20 kilojoules. Like this, we have to calculate overall activation energy from Arrhenius equation. Already you know Arrhenius equation K is equal to A into e power minus EA by RT. So overall rate constant K, given a overall rate constant K is equal under root K1, K3 by K2. So based on this given data, can derive overall activation energy like this. Next question. Question number 12. He given two statements. Statement 1 is like this. Question number 12. Statement 1. Oxygen bond length in ozone is greater than O2. Oxygen bond length in O3 is greater than O2. That is statement 1. Next statement 2. Oxygen bond order in ozone is oxygen bond order in ozone is 1.5 and oxygen bond order in O2 is 2. Here bond order is 2, here bond order is 1.5. Which one is correct in this case? First option given, both statement 1 and 2 are true. Second option, both statement 1 and statement 2 are false. Third option, statement 1 is true, but statement 2 is false. Fourth option, statement 1 is false, but statement 2 is true. Which one is correct? Which one is correct option in this case? Suppose we take statement 1, oxygen bond length in ozone is greater than O2. Is it correct or not? Already you know the relationship between bond order and bond length. Bond order is directly proportional to bond energy and that is inversely proportional to bond length. Whenever bond order increases, bond length decreases. Already you know structures of ozone and O2. It is a structure of ozone. Its bond order is 1.5. Already know structure of O2 molecule, its bond order is 2. Whenever bond order increases, bond length decreases. So here, which one has a more bond order in this case? Oxygen. Whenever bond order increases, bond length decreases. Which one has less bond order? Ozone. Ozone bond order 1.5. So whenever bond order decreases, bond length increases. So he given oxygen bond length in ozone is greater than O2. This is correct option, no doubt. In second statement, he given oxygen bond order in ozone is 1.5 and O2 is 2. That is also correct. So statement 1 and 2 both are correct. So first option is correct. That is from chemical bonding. Next question. Question number 12. Sorry. Question number 13. Question number 13. The given matches the following like this. The given ions and their magnetic momentum. Magnetic momentum in both magnetons. Mu. In first case, is given titanium plus 3 and its magnetic momentum value 2.8083. Second one is scandium plus 3. Its magnetic momentum, it is P, Q is 0. Third one is vanadium plus 2. Its magnetic momentum 1.73. Next, fourth one is nickel plus 2. SO is a 3.87. He given 4 different options. So which one is correct option? This is correct matching. So what is the magnetic momentum? How do you find magnetic momentum? Magnetic momentum formula. Whenever number of unpaired electrons increases, magnetic momentum value also increases. So how do you find magnetic momentum? Magnetic momentum formula mu is equal to under root n into n plus 2 Bm. Suppose we take titanium plus 3, number of unpaired electrons in titanium plus 3. What is the electronic configuration of titanium plus 3? What is the electronic configuration of titanium? Argon 4s2 3d1. 4s1 3d2. 4s2 2d2, but it contains a 3 positive charges. So remove 2 electrons from this, 1 electron from this. So then it becomes 3d1. Number of unpaired electrons in this case only 1. Number of unpaired electrons in this case 1. So therefore mu is equal to 1.73. If you substitute a 1 in this case, then it becomes 1.73. So magnetic momentum of titanium plus 3 is 1.73. If it is scandium plus 3, what is the electronic configuration of scandium? Argon 4s2 3d1, but it contains a 3 positive charges. If you remove 3 electrons, then number of unpaired electrons becomes 0. So magnetic momentum also 0. Suppose if it is vanadium plus 3, vanadium plus 2. What is the electronic configuration of vanadium plus 2? Its electronic configuration argon 4s2 3d3. But number of positive charges in this case 2. So remove 2 electrons from this. So then N becomes vanadium plus 2 electronic configuration becomes 3d3. N value in this case 3. Number of unpaired electrons 3. So its magnetic moment 3.87. Then nickel plus 2. What is the electronic configuration of nickel plus 2? Its electronic configuration argon 4s2 3d8. The number of positive charges in this case 2. Remove 2 electrons from this, then it becomes 3d8. So electronic configuration of 3d8 is like this: 1, 2, 3, 4, 5, 6, 7, 8. Number of unpaired electrons in this case 2. N is equal to 2 means it's a magnetic moment of 2.83. So in this case, magnetic momentum of titanium plus 3 is equal to 1.73 bm. Next, magnetic momentum of scandium plus 3 is equal to 0. Next, magnetic momentum of vanadium plus 2 is equal to number of unpaired electrons in this case 3.87. Magnetic momentum of nickel plus 2 is equal to 2.83. He given 4 different options, so we can understand like this. Next question, question number 14. Consider the following reactions. Question number 14. Consider the following reactions. Consider the following reactions. First one is S plus 3/2 O2 gives SO3 plus 2x kilojoules. Second one is SO2 plus half O2 gives SO3 plus y kilojoules. Calculate heat of reaction for the given reaction. For the given reaction, that is S plus O2 gives SO2. We given 4 options in this case. First option is minus x plus y. Second option is minus 2x plus y. Third option is x by y. Fourth option is y minus 2. How do you find heat of S plus O2 gives SO2 reaction? That is a given question in this case. Solution for this. In this case, it given heat of reactions. Heat of these two reactions like this. S plus 3/2 O2 gives SO3 here. Heat of reaction is at 2x kilojoules. So first one is Actually, both are examples for exothermic reactions. For exothermic reactions, delta H value is negative. So here S plus O2 gives S plus 3 by 2 O2 gives SO3. SO3. In this case, heat of reaction is at 2x kilojoules. So what the sign of this place? So suppose if you take delta H, then it becomes minus. So indirectly you can also write delta H is equal to minus 2x joules. Both are correct. Both are the correct representations of exothermic reactions. Second one is here SO2 plus half O2 gives SO3. Suppose if it is reversible for this, if you take opposite reaction for this, then it becomes SO3 gives SO2 plus half O2. So here delta H is equal to Y. Whenever reactions are reversed, then heat, the signs of heat also will be reversed. So here delta H is equal to Y. Suppose, so in this case we have to find heat of S plus O2 gives SO2. If we add these two equations, then we can get this equation like this. Suppose if you add 1 and 2, if you do 1 plus 2, then we will get, in this case SO3 cancels, so S plus 3 by 2 O2 gives SO2 plus half O2. So that is nothing but S plus O2 gives SO2. So add these two equations. So therefore delta H is equal to heat of this reaction, net reaction is equal to delta H1 plus delta H2. Just assume it is delta H1, it is a delta H2. So that is equal to delta H1 value is a minus 2x, it is a plus y. So this is the correct answer in this case. So here correct option is y minus 2x. Y minus 2x. It is from thermochemistry. Next question number 15. Question number 15. In this case, we given again two statements. Statement 1 is like this. Statement 1. IE1 of Sn is greater than 11. Second statement is IE1 of silicon is greater than germanium. So again, given four different statements. First one is both statement 1 and statement 2 are true. Second option is both statement 1 and statement 2 are false. Next third option, statement 1 is true, statement 2 is false. Next fourth option, statement 1 is false, but statement 2 is true. Which one is correct option in this case? Already know IE value of fourth group elements. Fourth group contains carbon, silicon, germanium, tin, lead. So what is the order of IE of fourth group elements? From carbon to lead, generally IE value decreases. But one exception is there in this case. Indirectly, order of IE1 of fourth group elements is like this. Carbon is greater than, silicon is greater than, germanium is greater than, next lead is greater than tin. It has one exception case in this case. IE of lead is greater than tin. So in this case, in first case, given IE1 of Sn is greater than lead. That is wrong. First statement 1 is wrong. Statement 2 is correct. Next question, number 16. Question number 16 is like this. When ethane 1,2 diamine is progressive added to aqueous nickel to chloride, the sequence of color change observed will be. Question number 16. Ethane 1,2 diamine is added to nickel to chlorides in aqueous medium. when ethylene diamine ene is added to, is progressive added to aqueous solution of nickel 2 chloride. Nickel 2 chloride. The sequence of color changed observed will be he given 4 different options. First option is pale blue to blue, blue to green, green to violet. Second option is violet to blue, next blue to pale blue, next pale blue to green. Next third option is pale blue to blue, next blue to violet, next violet to green. Next fourth option is green to pale blue, next blue, next violet. Which one is correct option in this case? Already you know nickel chloride in aqueous medium. Whenever nickel chloride is dissolved in water, then it becomes a hexa-aqua nickel 2. NiH2O 6 times plus 2. So what is the oxygen state of nickel in this case? Already you know H2 is a neutral ligand. Oxygen state of nickel is plus 2. So what is the color of nickel plus 2? Green. Whenever this compound is treated with ethylene diamine, ethylene diamine is a bidentate ligand. Bidentate ligand. So whenever this compound reacts with ethylene diamine, then 2 water molecules are replaced by 1 ethylene diamine. So that gives NiH2O 4 times ene plus 2. So color of this complex is pale blue. If you take another ethylene diamine, ene, then again 2 water molecules are replaced by ene. So that gives NiH2O 2 times En2 plus 2. Color of this compound is blue. Whenever it is treated with another ethylene diamine, then these remaining 2 water molecules also replaced by ethylene diamine. So that gives NiEn 3 times plus 2. Color of this is violet. So in this case, green is converted into blue. Sorry, pale blue is converted into blue, and blue is converted into violet whenever number of ethylene diamides increases. That is question number 16. So in this case, correct option is 4. Green to pale blue to blue, blue to violet. Okay, thank you.